Hello again. We welcome you for the WeLEAP Enlightening Talk series. And this is the part 2 with Dr. Nadia Figueroa. Those of you who missed part 1, it will be linked in the description below. We have been talking with Dr. Nadia Figueroa about her career journey. And now in this part, we will go into more details of the research projects she is conducting in her lab. And we will also learn more about her day-to-day life as a new faculty member at University of Pennsylvania. So welcome to all the audience, and thanks, Dr. Figueroa, for staying with us. Yes, we can see that.
Okay. All right. So yeah, so I'm gonna just give a quick overview of the research that I've done so far, like during my PhD and my postdoc, and now what I'm working on as a new assistant professor. So I just started in January. So the projects that I'm working on are still very much linked to students that I work with at EPFL and MIT. I have 3 PhD students that are coming in to join my group in the fall. Some of the works that I'm going to talk about are with the students that I'm working on currently, and some ideas of what I'm interested in working on with my new PhD students, and also master students that I'm going to work on during the summer. So yeah, as we already talked about, so I did my PhD at EPFL, postdoc at MIT, and now I'm assistant professor at the University of Pennsylvania, where I will lead the collaborative HumanAware robotics lab. The CHAR lab for short. That's the acronym that I came up with, and that's the name that I'm happy with now. And what collaborative HumanAware robots means is basically being able to develop robots that can interact and physically collaborate with humans in a seamless and safe manner. As you can see here in this video from one of my PhD works, where the robot is basically taught to do a pick and place task of picking these blocks, passing them through this inspection line, and placing them on the target's location. But as you can see, the human is capable of grabbing the robot, adapting it to grab another block or another product, and the robot just allows that type of perturbation and is capable of planning on the fly. So that's what kind of like collaborative HumanAware robotics actually means. So being able to develop controllers and learning algorithms for robots such that they are aware of the human, they're aware, and they can collaborate with the human in order to help us with our daily lives, which is kind of like the vision that every roboticist has. So I'm going to talk about some of the works that I've been doing towards this goal. But before that, I want to show just kind of like what the state of physical human robot collaboration is currently, at least in industry. So typically, like when you go to a factory, you see a robot kind of like caged in a cell, right? So there's fences that are caging the robots, and the human is not really inside the workspace, or it's not really close to the robot, because if the robot is simply doing a task that it was programmed to do, like it's not aware that the human is there. And this might impose danger to the human, right? So right now, what most collaborative applications are basically where the human and the robot are kind of like in the same region without the robot really being caged, but there's not much of a physical interaction yet. So like so if the human comes close to where the robot is, the robot just stops, or the robot slows down. But obviously which are these coexist, what we call coexistence and sequential collaboration. So that's what currently what we can currently see in industry, and the types of collaborative robots that we see today are kind of like failed in this type of collaboration. But what I focus on is on the more advanced collaboration, where we want the robot and the worker to be working on the same parts or like same products, to be able to, for example, cook a pizza together, be able to assemble a product together in the production line, and also being able for the robot to be able to respond in real time to the movements or to the intentions of the human. And that's what really my research is focused on, being able to develop these more advanced applications, which currently do not exist in industry or in our or any other type of application, because we're just not there yet. We still can't ensure that a robot will be 100% safe, that a robot can detect all of the intentions of the human, and even that the transfer of knowledge between the human and the robot is efficient. So currently it's very inefficient to be able to program a robot. So you need to be a roboticist, or you really need to understand like how to program a robot. It's very difficult to program them. So my research is really focused on kind of like going into this domain of being able to develop physically collaborative robots. And if we can understand, for example, how humans physically collaborate, then we can develop controllers or like some theory about how humans collaborate and pass it on to robots, so that robots can physically collaborate safely and fluidly with humans, or even have multiple robots collaborate with that are different. You know, maybe like one arm collaborating with a drone, or an arm collaborating with a quadruped. Like if we can understand this kind of like this very nice way that humans adapt and collaborate with each other, like then we can be able to develop the controllers for robots in order to reach that type of collaboration as well. So that's kind of like what's really interesting for me. So like what are the key pros? So this is just kind of like the goal, but there's so many kind of like applications or sub goals that we need to accomplish before even reaching this type of collaboration. So yeah, so of course, like some of the motivation behind this work, behind reaching that goal is being able to have robots kind of like help us in our everyday lives, right? Like so robots helping us in factories and in warehouses, in the workplace, how you see in this video. So these are works that I did during my PhD. Or even household activities like helping us peel vegetables, do the kind of like repetitive things that we don't really want to do. As well as being able to develop these kind of like collaborative strategies that will help us, for example, handle large or bulky objects like you see in this video here, where the robots can kind of like seamlessly grasp like a big object from a human that is holding it. Or even helping us, you know, like clean out a shelf from our rooms. So these are kind of like this is what motivated me like to go into this field, because this is kind of like the vision that everyone as a roboticist has, that we want robots to be able to help us in these type of activities. But in order to do that, we need to solve a lot of problems beforehand, right? So the approach that I take in order to be able to make this collaboration and this learning of tasks more efficient is basically learning from the human. So and it's inspired basically by how humans learn from demonstration, right? Like if you go to a cooking class, you see the chef that's cooking and giving you instructions, and you're basically learning kind of like what the instructions are, and you end up doing it by yourself, and then you get some corrections by the chef if you're doing it wrong. So that's learning from demonstration. It's a very efficient way for humans to transfer knowledge to robots without really being an expert roboticist, without really even knowing how the robot works. You basically just do the task with the robots, and when you're doing it, so we basically collect data. So we're collecting data from the sensors of the robots, from vision sensors that can track the objects, and then we build up models for this for the task, so that then the robot can perform them autonomously. So that's kind of like one approach. And yeah, so and then the other approach that I really like to focus on is on the collaboration part. So like how to make this physical collaboration kind of like as efficient as possible.
Yeah.
So,
just a second. So I just wanted to make a comment on the previous slide. Like, somebody watching outside of the robotics community, they may question, like, why are we making robots to do household activities? Why we can't just, hire a human for to do that? But the goal here is to learn from those activities as an example, and then the bigger goal is to use robots in extreme environments, right? Such as International Space Station or oil drilling facilities where humans can't go or can't perform. But these are just examples from simple activities we do daily to train the robots. So
Yeah.
yeah, I just wanted to highlight that.
And also, I mean, you can think about if robots can acquire these type of skills of performing kind of like everyday tasks, then they can help, for example, people that have suffered from strokes and have limited mobility.
Right.
Then it would be very useful to have a robot that is capable of doing all of these manipulation skills that the human itself can't do, but the human is there kind of like supervising or telling the robot, oh, peel this vegetable, and you just hand it to the robot and the robot does it for you. Or even help you, for example, doing physical therapy. If the robot knows exactly how to do all of these manipulation skills, then the robot can help a patient that is trying to recover from limited mobility. Also, as you said, kind of like in scenarios where the robots can't really, where human like search and rescue, like if it's better obviously to send in a robot to manipulate cables and things like that, than having a human do it. So like it's really it's not really my focus is not on replacing the human at all. Like it's more about developing control strategies, or basically like the brain of the robot that can collaborate with the human to just make our lives easier, not necessarily replace our jobs, not at all. At least that's not my that's not my goal. Maybe from other professors it is, but for mine it's not, it's really not. And that's why I focus really a lot on the human awareness. So like it's more about, if we know if we can leverage what the competences of a human is versus what a robot can do. Like a robot can be very precise, while a human has more high level decision making power than the actual robot. So like how can we bring those two competences together such that we can just be more efficient in our day-to-day lives? It's not necessarily about replacing, it's more about enhancing the human experience.
Yeah. And I would just comment that perhaps we also need robots as a human replacement in certain situations. For example, countries like Japan and Korea, etc. Like there is a huge like the way the population is growing now, they have more and more elderly people, and there are not enough young people to take care of them. And it seems like a very easy task to to shift one physically disabled person from the wheelchair to the bed. But if a robot has to do it, it involves intense programming. So
Yeah,
I am really
skills like being able to handle like the way the interaction forces, and then while being safe and not not harming the human.
Right. Like, yeah, so I'm really inspired by the work you're doing, and it definitely has a lot of value and applications. So yeah, tell us more about that.
Yeah. So, and I like what you mentioned about like the population in Japan, because definitely, I mean, that's something, as you said, like from a perspective of someone coming from a developing country, then you can think of, oh, we can just hire someone to do all these things for us. But like in Japan or in these more advanced countries where the rates of births is lower than the people actually I mean than the lifespan of the people. So like there's just more older people there, so they really need elderly care and no one wants to do it. And that's one of the reasons why Japan is actually so advanced in adopting robotics, like for these type of applications, because it's something that they really need. And not just that, just imagine, for example, something like a pandemic where imagine the new pandemic comes in and people don't want to get the sickness, like the nurses don't want to be exposed to any of this. Like then you can teleoperate a robot, you can teach a robot how to help these humans that have these contagious diseases while keeping the doctors and the nurses safe as well. So like there's really a lot of applications for that. Like, and in order to do that, like we really need to understand how the physical world works, like how robots can manipulate and how they can navigate, you know, in these human, very dynamic environments, which are not like a factory where everything is known. Like there's so many uncertainties that the robot really has to understand in order to be safe and then be able to manipulate objects and navigate in the world. So that's why like my work really is very interdisciplinary. So like I use a lot of techniques from machine learning, from control theory, specifically dynamical systems, so robot control, kinematics, dynamics, perception, planning, and artificial intelligence, like being able to model humans, like but through the biomechanic, even the psychological ways of like how humans will be able to trust and build confidence with, of robots, and how they can adapt to robotics. So one of the main, so this is, I'm just gonna be very like high level of the technical part, but like one of the main kind of like contributions or methods that I use is basically assuming that the motion of the robot itself is modeled as a dynamical system. So like the robot itself is a dynamical system, right? Like it has inputs where you give it like certain torque and then to the motors, and then the robot moves. So that itself is modeled as a dynamical system. But if we model the motion of the desired motion of the hand, for example, or of the arm as a separate dynamical system, then we can use have some very advantageous, let's say, properties or behaviors for our robots. So for example, let's say this dynamical system is this first order differential equation, like x dot equals f of x. X is the position of the hand of the robot, let's say, and x dot is the velocity. So if we model the motion of the robot, like using this equation, what we have is basically this kind of like goal-oriented vector field, right? So where everywhere in the space, the robot actually, this equation kind of like tells us how the robot should evolve to a target or to a trajectory or to, for example, reach the hand of the human. And if there's some sort of perturbations, you have this kind of like global description of how the robot should move towards that target. And we can ensure that kind of like convergence using imposing constraints on this equation that we can either formulate mathematically or we can learn from data. And that's really cool, because then we can basically generate robot motions that are like extremely fast. For example, throwing objects to flying objects to a robot, like you can see in this video. So here, what the robots are doing, they're basically tracking this flying object, and because of the way that we formulate the motion of the robots, they can very quickly adapt and reach this flying object. As you can see, this video is actually sped down 1/8, so like it's actually super fast. Mm-hmm. And apart from so here you can also see like this concept of adaptability, right? So like typically robots, when you program them in factories, they're just following a trajectory that you give it, and then that's it. Like they just want to follow it, and that's why they become very unsafe when the human is in the vicinity of the robots. But if we can use these type of controllers that are adaptive or that are like robust to these perturbations, then the robot basically knows what it has to do and knows that it has to follow some trajectory. But if it's perturbed for some reason, either because the robot failed, one of the motor failed and it can't move, or the human just is playing around with it, it's messing with it, which you can think of, this could be something realistic, like a kid could come in and push the robot away. Here we can basically ensure that the robot is kind of like allowing these perturbations, but when the perturbations are gone, then it just continues on doing its own thing without really imposing any harm or adding any errors, like to the system or to the robot control itself. And this strategy, like it doesn't, it's not it's not restricted to only being used for arms. Like it can be used for a lot of types of robots. Like for example, I've tried this on being like controlling like wheelchairs, that you basically trace out like what trajectory you want the robot to follow, and then you learn this control law that has this kind of like vector field that tells the robot how to move. Here you can see how we use the same idea for humanoid robots, where we taught it like how to follow this track that you see on the floor. And you can kind of like push the robot away, and then it just kind of like allows that perturbation. So it's like it's compliant, so it's passive to the world. Which is kind of like how humans are, right? Like if you're walking down the street and you suddenly like bump into someone, then you have some sort of compliance there, like you have some hesitation, and then you go back to your own path. So that's the whole idea of like, can we build controllers or these type of algorithms that allow robots to have this type of adaptive behavior, being able to react, you know, like to changes or to these perturbations, just like humans do. Because if we want these robots to actually be working in the physical world where there's humans all around, there might be other robots moving around them, like they should be able to react. And that's kind of like the whole thesis, you know, like of my research, being able to generate controllers or learn controllers from for robots that are reactive and that are adaptive, and that at the same time are capable of reaching like the goals that the robot wants to do. Because if we only focus on being able to have like the optimal strategy or the optimal behavior, like a trajectory, you know, like the fastest trajectory of the robot, then it's very difficult to impose all of these safety, you know, like constraints that come with the robot actually operating in the physical world with humans. So yeah, so that's kind of like one of the main strategies that I use to kind of like go towards this collaborative human-aware robotic systems, where we model basically the motion that the robot should follow as a dynamical system that is reactive and that adapts on the fly. And it can be applied to many, you know, like applications with different types of robots, with multiple robots, with a robot and a human. So one of the so apart from that, so that really goes into this slide where I like to show kind of like what are the actual requirements of physical human robot interaction. So from my point of view, there's three very important ones, which are learning, so being able to teach the robot in the most efficient way the task that you want it to do. Adaptation, apart from learning in an efficient way, whatever the robot learns should be able to adapt to changes, right? Because if I teach you, for example, how to peel a potato, and then I give you a carrot, like we know that we have to do exactly the same motion. We know we just need to adapt the way that we apply forces on this new object that we got. So that adaptation is really what's important, I think, in order to build robots that are intelligent and are capable of adapting and collaborating with humans in the physical world, which is always changing. And then obviously safety. So like these are the three. So safety for the humans and safety for the robots themselves. So like safety, the robots obviously, which we don't want to damage them. We don't want them to be able to like be colliding with the environment or colliding with the humans. So like there's really these kind of like three thrusts of research, and this is the kind of like what I'm focusing on now in my group. So like my PhD students will basically work on either safety or learning strategies or adaptation, or a mix of all of these three, which are not necessarily orthogonal, right? So like we can approach safety concerns using learning, using adaptation strategies, and the other way around as well. So but these are the three like main things that I'm really interested in, and I think that we should really focus on in order to have these kind of like physical human robots collaboration strategies that we really like. So yeah, this is some ongoing work that I wanted to show about. So for example, here we're teaching a robot how to scoop like material from one bowl to the other. And what's cool about it is that not only can the robot adapt to kind of like physical perturbations that the human is doing, as you can see there in that video, but it also understands that once these perturbations are done, the actual high level task of transporting like this material in the scoop from one bowl to the other fails. So it knows that it has to go back and scoop again. And this is something that is difficult to learn, like because we're kind of like adapting at different levels, right? We're adapting at the physical level, but we're also adapting kind of like at the task level, which I think is really interesting because these are realistic things that could happen, you know, like in the kitchen. Like if you teach a robot just to do some scooping, to do some to prepare some parts of the recipe for you, and suddenly you bump into it, and then it just like the chicken falls, or you know, like the broccoli falls or things like that, then it has to know that, oh, something went wrong, I need to go back, you know, I need to go back and start all over again. And these strategies are like what I think are really important to look into. And this is ongoing work also with a student at MIT.
Mm-hmm.
And yeah, so this is more about adaptation. So like most of my work so far has focused on what I call kinematic adaptation. So basically adapting to motions, right? So adapting to motions, like if the object is moving, the robots kind of like the motion of the robots adapts to like grab that moving object. But what I'm really interested in now, right? Like for example, when two movers are moving like a big painting or a large couch, they use a lot of like communication, like, oh, go left, go right, go up. Like they use a lot of like communication, but that's something that's limited between a human and a robot. But apart from that, we also use our sensors of our hands. Like we can also detect, like if you're pushing me, I know that I need to go in one direction, or that I need to rotate. So how can we develop strategies for a robot to be able to detect what's the intention of the human when the human wants the robot to basically assist in like these tasks where you really want to carry something together. For example, imagine like loading or unloading, you know, like things from the trunk of your car. Like that would be really cool for a robot to be able to help you like do these type of things, and which will reduce the fatigue of a human body and will reduce the effort of the human as well. So it's all about how to adapt to these situations. When should the robot assist, and how should the robot assist, like physically, is to basically help the human not harm its own body physically if it's doing too much effort on these tasks. So that's what something that I'm really excited about. And yeah, so and the last thing is obviously about safety also. So like safety, here you can see a video where it is the work from my PhD, where we developed this strategy such that the robots allow for these kind of like perturbations from the human. Now we have two robots. So imagine if the robot is allowing for perturbations, then it can crash onto the other robot if we don't have a strategy to avoid that. So here what we did was we came up with a strategy that used machine learning to basically allow for these perturbations, so that allow for the robots to be compliant, but at the same time, basically ensure that they don't crash into each other. And yeah, so here you can see a cooler video of this. So here the two robots are trying to track the markers that you see like on the hands of my colleague, Sina. And here you see that the robots are basically tracking them and just trying to avoid colliding as without while reaching these targets. Yeah, so and then the last part, this is also work that I did with a PhD student at MIT. So here we focus more on the human safety part, right? So like now, if we can ensure that the robot doesn't collide, for example, with another robot or with the environment. But then what happens when we want to avoid to make this whole physical human robot interaction safe as well? So one of the things that happens, as I mentioned before, is normally if you treat safety for humans just thinking about collision avoidance, then the robot basically freezes. So like let's say the robot is here and the human comes in the workspace, a robot is moving, the human comes in and then the robot just freezes and stops doing its job, because it just that's just kind of like the whole idea of collision avoidance. Let's just not collide with the human. But what happens if we want the robot to dress a human? Or if we want the robot to if the task that the robot has to do involves actually making contact or being very close to the human. So then focusing just on collision avoidance is not enough, because then the robot will basically just be frozen all the time. So what we did was we developed this kind of like new idea of human physical safety, where a human will be safe around the robot. What if the robot is capable of avoiding collision, but if collision is unavoidable, then try to minimize the impact as much as possible. So like if the robot actually has to make contact, then try to reduce that contact and try to reduce the force basically that the robot is applying on the human's body. And that's this whole idea of mixing these human aware motion planners, which focus only on collision avoidance, with compliant controllers. So with compliant control, you basically control for forces. You control for reducing the contact force between the human and the robots. And here you can see how just by doing that, we can actually provide an even more efficient performance of the task. So on the left here, we have a motion planner that considers safety as collision avoidance or safe impact. So you can see that it achieves a task much faster than the one on the right, where it just considers collision avoidance. So basically the one on the right just kind of like got stuck there. Like it just doesn't know, because it just got really close to the human and then stopped.
Yeah.
So this is kind of like the ideas that I'm really excited about as well, of like how to ensure and what the safety actually mean. It really depends on the context of the task, and also depends on like the trust or the confidence that the human also has on the robot, or what the task is. Like if the task is about dressing or about doing something physically to the human, then focusing solely on collision avoidance, like it will make the robot very inefficient, or maybe not even reach the task correctly. So we have to think about all of these other implications, or all these other problems that come into play when the robots are really physically interacting with the human. So that's about it. So on the left, you can see, for example, these three main topics that I'm really interested in and that I've been working on from my PhD to now. So like safety, adaptation, and learning, and then the different applications that I've applied these algorithms on, which are like industrial warehouse, household or everyday, and even rehabilitation and assistive robotics. So these are like the three kind of like application domains that I'm working on focusing on in my group.
That's wonderful. I think you are hitting on all the challenges in the robotics and taking it to next level. Thank you for sharing. I almost feel like, doing another PhD with you, but I will hold that thought. But I will take the opportunity to everybody watching here. If you are interested to join Dr. Figueroa Labs, then contact her, and I will be giving the link to her lab webpage in the description.
Yeah.
So, well, we saw all that amazing work. So I will now ask you, how did you develop your research vision when you were actually like preparing for faculty career? So I think one of the main, challenge is, okay, what should be the research vision? How can I do something innovative in the industry? So how did you do that?
Well, for me, it was a very iterative process. Like what I presented to you now, I kind of already had an idea about it when I was writing my statements, but it wasn't as clear as I have it now. So really what helped me was writing the research statement and then sending it to my mentors, to friends, and then they getting comments, and just really going through the whole interview process, because this is what they ask you. So like when I think it was during my second or third interview, the second interview with the second university, after the whole interview day, I thought, okay, it's three things: safety, adaptation, and learning. But I didn't have that really formulated until I had to talk about it with many people. So at least that's really what helped me. I mean, my research statement was covering some of these topics, like at some level, but from my point of view, now that I read it, like it's not as clear cut as how I'm presenting it now to you. So for me, it was really a matter of discussing it, you know, like with multiple people from different backgrounds, and with that you kind of like figure out what makes sense and what resonates more. And even with like in your own mind, you know, like when you're explaining it over and over and over again, then you start thinking, oh, this is what makes sense, this doesn't, or I can formulate it this way such that it comes out as something that was pre-planned or pre-thought, but it actually kind of like came up, you know, like while discussing it with someone. But of course, I mean, you need to spend a lot of time on doing that and thinking about, and not just what you did in your PhD, but also I think what helped me really a lot was doing a postdoc, because that like if I think about what I would have written when I just finished my PhD, compare of what I wrote like a year ago, and then compare what I would write now, it's, you can see a progression of ideas, and you can see a progression of like, okay, I'm still kind of like using a specific school of thought or a specific way of approaching problems, but now I can see where the gaps are, you know, like to actually bring what I was claiming in my PhD to a next level. And that takes time. That takes obviously reading a lot of papers, reviewing a lot of papers, like becoming associate editor, for example, for journals and things like that, attending workshops, giving talks where people from different fields, from different departments, just ask you different questions that really, from different universities, that really helps you in kind of like building up, you know, like this whole story that you have to come up with when you're applying for the faculty positions.
Yeah, that's exactly true.
Yeah.
Yeah, thank you for sharing. So now you have been on the both sides of, you know, faculty career, like first you applied and now you are a faculty. So do you have any advice for the fresh PhD students or postdocs who are aspiring for faculty career? So apart from all the things you already mentioned, what can make their applications, you know, outstanding? And of course, like not everybody has same set of qualifications and achievements. So let's say if somebody does not have that many papers or not that many awards, so what is like one of the key things they should focus on, or not only one, maybe like a couple things?
So what's really important is the vision that you have. And I know this because now I am actually on the other part. Like I've been on a faculty hiring committee now this semester, and I've seen what they expect, and they expect you to obviously be very aware and confident about what you've done so far, but have some vision as to like how your experience, or like your expertise, how you can apply it to projects or problems that will have a much broader impact than what you've done so far. So it's really all about like impact and vision, like those two things that are what committees are searching for. Like even if you're kind of green and you haven't even finished your PhD, like if you have that, then that really pushes you ahead, because then that could because obviously like the people that are evaluating you are professors from different fields within a department. Like they might not all be experts in robotics, they might not all be experts in aerospace. So you really need to get through to all of the committee and to all of your future colleagues that the research that you're doing is interesting and it has impact, and that you have that vision of how to bring your expertise forward into those goals that you have, you know, like for the future. That's really what's really important. Obviously, like having a lot of papers, that helps as well. Having teaching experience helps, depending on the university. Like there are some universities that really focus on teaching or expect you to teach like right off the bat. So that's something that you really need to consider when you're applying. Like different universities or institutes have different requirements. So you really need to focus on that. And And nowadays, like the other thing that you have to write is a diversity statement. So that's also super important. And it's what's important is that you write something that's personal, and that's not like a template statement or of like, oh yes, diversity is an important issue, I want to do something about it. Like, that's not enough. Like, really, that's not enough. Like you need to really show that you understand, you know, like what the issues are related to discrimination, to racial bias, to all of these things, and have like a just be compassionate of it. Show that you're compassionate about these things, not just say like the template things that you find on the internet of what you should say. And approach it at a more personal level, for sure. I think those are the main things. I mean, obviously, apart from everything else, you know, like you have to have a lot of paper, not have, but like if you have a lot of papers and you have a lot of invited talks, then that brings you over the edge as well. But those things like vision, impact, and being, you know, like having this understanding and compassion about the issues of diversity that happen in academia, that's what everyone is looking for right now.
Right. Yeah, I asked that question because, you know, oftentimes people just get discouraged because, you know, when they apply and they are not hired, they just think of reasons being like, oh, I don't have enough papers, or maybe I don't have enough teaching experience. But
yeah,
that's only the, you know, one piece of the puzzle. Like, you need a lot more.
Yeah, I mean, that just puts that's just something that helps you meet all of the requirements. But then then what really you really need to show is that vision, and that's the impact that your research can have. You know, like why should they hire you? Like and when you're not like when you're rejected from one department or the other, it might not even be that's your vision wasn't good or anything like that. It just also might be a matter of fit, a matter of like, oh, that department actually was looking for some other expertise to fill a gap within that department. Right. So like, you shouldn't take that rejection like so personally. Like, really, like, you just it's a matter of working hard and luck. Really, like applying at the right time. Right. Yeah. So yeah.
Yeah, it's good that you shared that, because I really wanted to highlight that, you know, it's not that faculty career is meant for only some specific people who have a lot of research already. Even if you decide of being a faculty member during the last year of your PhD, you can still do that. So yeah. Thank you for sharing that. Okay, so I see, like, you know, as I mentioned in our first part, you have several awards in your bag. So I wanted to, you know, like people in their PhD programs or in their early postdoc journey, how they should, you know, achieve for these kind of awards. Like, how was your approach? Like, how did you get to know about, like, okay, there are these awards, maybe I should apply for these? Because oftentimes what happens, like, people are not even aware of these. So
yeah, that is definitely a problem, that people are not aware of these awards, and most of these awards are like self-nomination. Like, you send your information and then there's a committee that selects you or not. So like for the KUKA Innovation Award, that is a very well-known like competition in Europe, but because KUKA is in Germany, and it's just something that they were using to kind of like advertise their robots, and showing that they invest and they collaborate with research institutes. So we were already aware of that. And how it happened was that me and Sina, my colleague, like, we started our PhD together. We worked on a lot of these of the projects that I presented today together. And we said, like, we want to try it. We wrote a proposal. We showed it to our professor, and she agreed. She said, as long as it doesn't deter you know like change your path so much of your PhD, and that it helps you, you know, like for your development, then go for it. So we wrote it. We went through all the process of like selection committees and all of that. And we ended up reaching the top 5 finalists. And how that award works is like, they basically, you present an idea that you want to showcase at this big Hanover fair, which is like the biggest automation fair in the world, literally, and happens every year in Hanover. And KUKA offers, so if you reach that top 5, they offer to lend you as many robots as you want to develop your idea, which is the cool part, you know, like maybe like, so there we needed 2 robots and we already had one, so we only asked for one, another one, and they helped us setting up the whole installation, the whole demo and everything like that. So that was the video that you saw with me carrying like these big automotive parts. So like it was that experiment. And yeah, so that was, and that was an amazing experience actually. So we had to go to Hanover for 2 weeks, install the robots there. We had to have our demo working, basically plug and play, you know, like there was no like if there were bugs, like you would see them because people would come and just want to play around and see how the robot works. So we had our demo working from 9 a.m. to 6 p.m. for 1 full week. So it was a lot of work, but with that work, I mean, we ended up writing a really good journal paper, you know, like talking about all the experience. We developed the different algorithms for specifically that experiment. We didn't win the award, but because that award it really focuses on like a product that's already ready for development. And we still needed we still had some gaps in the way we tracked the objects and things like that. But yeah, that was it was more kind of like intrinsically motivated, you know, like it was something like we wanted to do. We want to participate in this award. Imagine how cool it would be if we reach the finals and if we win. So like we tried our best, and we got a lot of publicity from it, like even if we didn't win. So that was basically how that award happened. And for the PhD award, that one, that one, I mean, there's a call for that award every year. They send an email to the robotics mailing list and they say, okay, there's a deadline for students to who finish their PhD in the last year to self-nominate, and you send your nomination, and then it goes through a committee of like some of the leading professors in robotics in Europe, and then they select you basically. So for that one, I wasn't really like, I didn't know that I was going to be selected, but I ended up I think I am one of the first female students actually to have ever been selected for at least to go to the finals, to go to the top 5 for that award. We had to present. So like we went to the European Robotics Forum in 2020, like right before the pandemic hit in Spain. Actually, I was in Spain in March. When I flew back, I went to give a talk, and then after the talk, then they selected the winner, and then I flew back, and that's when the pandemic hit. So like I was really lucky that I at least had that last experience.
Right.
But yeah, I mean, it's all about, you know, like being confident and being knowing your self-worth and putting yourself out there and nominating yourself. Well, most of these awards are self-nominations, or your advisor nominates you or things like that. So you just talk to, you know, like to your advisors. It really helps, obviously, that people knew already who I was, I guess, like at that point in my career, because I just traveled so much to all these conferences, gave talks in workshops, and then people already kind of like knew my work and the impact that it had. So that is something that's really I think that really helped me along the way. And now that you know, like COVID restrictions are being lifted, like what I really would advise to students is to go to conferences because that's the only way that people are going to get to know you, really. Yeah. Even virtually, you know, like right now, like almost everyone is getting to like adjusted to also going to virtual conference and things like that. So like even if they invite you virtually, like go for it, give a talk to as many people as you can.
Yeah, definitely. A lot of good advice you gave there. So I hope all the students listening to this talk, they can benefit from that. And, you know, they don't, I mean, we all learn as we go in this process, but here we are providing all these suggestions so that they can accelerate their progress. So thank you for sharing. So now let's move on to your life now as a new faculty member at University of Pennsylvania. So how is your experience? How was your first semester?
Well, it was, I mean, it was a lot of work. It was a lot of, I mean, it was an interesting transition from postdoc to assistant professor, just because you have no idea what are the day-to-day things that a professor really has to has to address. And it's administrative things related to the departments, like you have to be part of committees for PhD or thesis for other students. There's multiple faculty meetings going on all the time, like with the department, for the robotics professors. And teaching really takes a lot of your time. Like that was something that I didn't realize, that it would take so much time, just basically preparing the course and then dealing with all the logistics, because I'm like if my course were just theoretical and it was just me going and giving a lecture, then okay, it's not, maybe that's not much work. But my course is quite practical. Like we actually have robots. The students have to write code for and go to labs and do all these things. And so managing all of that, like it's a lot of work. Like I have 3 PhD student TAs, I have 5 master student TAs, and just basically managing this entire team, dealing with all of the requests from students and things like that. I mean, that's just something that really takes a lot of your time. So which I mean, it's quite rewarding, but I just didn't know what the extent of like how much time I had to time and energy I had to allocate to this. And I mean, I've talked to other assistant professors and they told me the same, like that the first time you teach is like that. So like you take like 3 or 4 hours to prepare for one lecture, and by the time that you give that lecture multiple times, and you can just go there and you already know what the slides are and you already know what to say. But at the beginning, obviously, you want to do it right, and you just take a lot of time to prepare for the courses. But obviously, like it's also something that is quite rewarding, because then you finish with the week and say, okay, I did my 2 lectures, I'm done, I did my job. Like and something that's, as a researcher, I mean, you don't really have that, because it's all based on the paper being accepted or not. So it's kind of like a more long-term, you know, like a more long-term return that you have. Whereas when you're teaching, like it's there, yeah, you see the students understanding the things that you're saying. So then you feel some sort of like fulfillment. So that's good. So that's something that's that definitely is something that's different, kind of like and that has changed my lifestyle, and also like the way that I live my life as well, because obviously you have to have the energy to teach, you know, like twice a week, and be able to, you know, like answer all the questions from the students, which some questions might be difficult, you know, like that you haven't even thought of, because students are so good, you know, like so you really have to be at the top of your game, you know.
Yeah, I think, yeah, I mean, as a faculty member, there are so many challenging things one has to do. And then, yeah, course design is one of the toughest ones, because, you know, I did not know much about it, because I had never designed a course myself. But recently I started taking this workshop through MIT Teaching and Learning Lab. And now I am realizing, you know, how much thought goes into developing a course. And it's not only about the content, but also about the delivery and being like accessible by diverse population. So many things. I hope students watching this can appreciate much more the courses their professors are designing for them.
Yeah, and also, I mean, I right now, so I started remotely, because I started this year. So and it was when Omicron's like it was that wave at the beginning of January, right? So like we were all still not being able to go in person to the university. So I started remotely for a couple of weeks, and then we transitioned to in person. But there are some students who still had issues with their visas. So some master students that were still in their home countries. So we had to provide, you know, like both at least like recorded lectures or hybrid, where I basically was teaching in person, but at the same time I had people in Zoom. So I taught the entire course in the hybrid form. So, and that's also something that as a lecturer, you really need to get, you know, like accustomed to like having your audience in person and also having audience on Zoom, not forgetting about the people on Zoom and not forgetting about the people in person. So it's a lot of, you know, adaptation, which is everything basically that I do in my, like adapting to the world and to all of the obstacles that the world and life brings me.
Yeah, I think the hybrid version is the most challenging because it's easier to handle one thing at a time, fully remote or fully in person. But like if it is hybrid, oh my God, lot of technological issues.
Oh yeah, I had a lot of issues, like the Wi-Fi went down, so that so it was yeah.
Well,
There's a
thank
lot.
you for sharing the experience. So, what would you say is the toughest part of being a new faculty? Like you mentioned course design. Is there anything else, or is that it for you?
Well, I mean, it's the course design and the managing time and energy, like managing your time well, like learning how to manage your time and your energy. That's definitely something that I'm still learning for sure. And because it's like as a postdoc or as a PhD student, like you can just be contained in your own office and then just work until late hours and not interact with anyone. But as a professor, you need to, like, you have meetings all the time, you know, like, so you really have to be kind of like at the top of your, like, you can't have that same lifestyle that you had as a PhD student or as a postdoc. Like there's something needs to change. Like there has to be a balance and there has to be some structure. Otherwise you won't be able to really perform the way that you have to. And one, apart from that, it's also just like being able, having to decide things like on the spot, you know, like oh, this happened, like, oh, like what do you want to do about your lab, or what do you want to do about this student, or what do you want to do, like it's just things that you need to do, like being, because you just have a lot of more responsibilities. And so then that's not that's just something that you don't have experience with, even being a postdoc, you know, because you're not managing a lab, you're just like you're just yourself, and you might be, you know, like supervising some students, but you don't have you know, like the whole picture, like you're not managing the money, you're not managing the funding, you like all the grants and all that stuff. So it's just a lot of learning, you know, like I'm still learning, like all the things, like every week of the semester there was just a new task that I had to do that I had no idea like how to do it, and I've never done before, and like, okay, but I have to do it, you know. Like, okay, yeah, like, okay, you're on the PhD admissions committee, so I have to go over all the PhD applicants. Like I didn't know that I had to do that, and then I did it. I didn't know how to do it, and I asked senior professors for help, that they helped me. And so it's just it's a matter of learning like all of the new tasks that are more high level than what we are that we have experience with as PhD or postdocs. So
Yeah, definitely a lot of challenges, and like continuously challenging yourself. That's what being a professor is. But it's also very satisfying at the same time, right? It's tough, but it's highly rewarding.
yeah, I mean, once you get out, once you get a hang of it, and once you know, like, oh, okay, so like if I'm gonna teach, like now that I finished my first semester, now I know that I shouldn't commit to like other things, you know, like to other external stuff, or not anything, but like not as much as I would do like as a postdoc, because you just don't have the time, and I won't have the energy to focus on everything like at the level that I really like to do things.
Yeah,
so
it's
it's just
about
a matter of
priority.
experience. Yeah. Mm-hmm.
Yeah, especially in your initial years. So, so how does your typical work day look like? And how do you stay motivated and, you know, like in balance?
Well, I mean, I wake up early. Before, like I wasn't really a morning person at all, but now I kind of like force myself to become one, but because that's just the way it is, you know, like there's meetings that you have to do like that are early. You have to teach, so like I have to prepare. I know that I need a couple of hours to prepare for the teaching there. So I just kind of like schedule like my week. There's a couple of, like, at least now I'm trying to have like a couple of days where I just have meetings. So because it's also difficult, like if I want to focus on, for example, going over a paper of a student, or reviewing papers, or writing grants, if you have a lot of meetings in between that day, then you can't really focus. So like I try to separate things and say, okay, I have 2 or 3 days where I schedule all my meetings, and then the other days I have more time to kind of like focus on things that I have to write, that I have to read and think about, things like that. So at least that's how I'm managing it. And now I don't know if I'm being successful, but that's what I'm trying to do. Because otherwise it's just very chaotic, because there's so many things coming in, and so many emails coming in also all the time, asking for advice, asking to join your group, like all these things.
Yeah, and definitely, like as a student, you can afford to skip activities if you are not feeling like it. But as a professor, you cannot. You have like a huge commitment and responsibility. I realized this because I have been teaching engineering design this semester to the high school students at MIT, and like it was like a boot camp thing the whole semester, and that just opened my eyes, so I can truly appreciate, and I hope everybody watching this now understand how tough it is to be a new faculty member, but at the same time it is doable, and as Nadia is successfully doing it, so we can do it. So next thing I wanted to ask is about, like, so sometimes actually, like, based on my interactions with young graduate students or postdocs, sometimes they feel like, oh, can I really do it? It seems like a lot of jobs being a professor. So and of course you mentioned a little bit about how you manage your time. Do you have any other like tips or anything based on your own experience, like how do you succeed every day towards a fully tenured position?
Well, I still don't have a fully tenured position, so I don't know.
But what is your plan? Like, what are you thinking may work?
I mean, I know what my mentoring committee and what senior professors tell me is like, I mean, you need to, like, the minimum job that you have to do is be a good teacher, at least at Penn. They really value that. So like, so if you have a check mark on your teaching, then that you're already like at a good standing. And obviously, and also like, the number of publications at this point doesn't really matter. What matters is the impact of those publications, and that people know your work. So that's why you see a lot of professors traveling around, giving talks, giving seminars in other universities. That's because that's what's needed for a tenure position. Like, people need to know about you. It's not about like it. You can have a whole bunch of papers, but if no one knows about your work, then you're not going to get tenure, basically. So it's and you have to mix, you have to have a find a good way to balance those two, like have balance being like having a very good, like a teaching experience, at the same time doing impactful research and getting it out there, basically. Well, that's my plan. that's
That sounds like a great plan, and we wish you good luck. It will definitely be successful. So yeah, with that, I would really like to say thanks for staying with us today and giving us your valuable time. And that's why I am, recording these sessions, so that we can have these valuable advice available for all, and people can benefit from that. So thank you so much for being a part of this. And any closing remarks or suggestions or tips you have for the aspiring women for having a long-term career in aerospace or even in engineering?
I guess, like, for women, it's always more difficult because we grow up with all, as we talked about in the previous video, like we grow up with all of these, like experiences that really shape how we behave. Where we want to show off, where we want to kind of like show that we're good enough and things like that, and we are riddled with the imposter syndrome. And that's I mean, I think any woman will tell you that they are still going through that, even if you see them as that at the top of their game. So what I would really suggest is just I don't know, speak up when you think you have, like a good idea. Be confident about yourself, and know your self-worth, and know that the way people see you is not really important. What's important is how you see yourself, and how you see yourself, and how you treat yourself. Like, that reflects on how people see you. So you don't really you shouldn't really care about like oh, they're gonna think I'm this or they're gonna think I'm that, you know, like just do what you want to do what makes you, what you're passionate about, and you're gonna be successful like that.
Mhm. Yeah, great advice. Thank you so much. And yeah, I can totally relate. As women, we are the most critical about our own self. So yeah, thank you for just reminding us that. So with that, thank you so much again for joining us. And it has been such a pleasure to talk to you and, share more about your experiences and all these tips and suggestions. I am really, really sure that everybody watching here will be learning at least something, and no matter what career stage they are in. So thank you so much.
Thank you for inviting me. I really enjoyed having this long conversation.
Thank you.